Okay, today we're going to be talking about nuclear fusion. So this is a process that happens in the core of the sun, and it's what allows for energy to be released. So there's typically a three-step process for fusion. So the first one is that there's a lot of hydrogen atoms. Now these hydrogen atoms are H1 isotopes, so that means that there's just simply one proton and there's no neutron in these atoms. So they're kind of just floating around. So when fusion occurs, you have two hydrogen atoms. So let's say these two, this one and this one. They're going to collide together, and once they collide together, there's actually going to be a change. The proton will become a neutron, and that will create what's known as a deuteron or a duotron. So this duotron is basically a hydrogen isotope, but it's not hydrogen 1, it's hydrogen 2. So that's your first step, step 1 of nuclear fusion. So for step 2 of nuclear fusion, you have another hydrogen atom, like this one right here, and it's basically going to collide with the duotron. So when they all fuse together, they now are no longer hydrogen, but they are helium. And that's because, remember, the two protons, the number protons indicate the actual identification of the atom. So there are two protons, not one. So that makes it a helium atom. And to be more specific, this is helium-3 isotope. So after step 2, your final step is going to be step 3. So that means that there's going to be these kinds of helium-3 isotopes floating around. So let's go ahead, we're going to create 2 of them. And what's going to happen is that these isotopes are going to, boom, collide together like this. Now when they collide together, there's going to be 2 hydrogens nuclei are going to be released. So these are going to be released, and then this helium-4 isotope is what's going to be left over. So, and those are essentially the 3 steps of nuclear fusion. Every time that there is some kind of fusion happening, then there is a release of energy, and that's why that occurs in the star.